If you left Earth right now and traveled straight outward, past the Moon, past Mars, past the asteroid belt, past Jupiter's violent storms, past Saturn's rings, past the faint blue glow of Neptune, at what exact moment would you officially leave the solar system? Would your instruments detect a change? Would there be a final object marking the boundary? A last planet? A final drifting rock? Or would you just keep going and nothing happens at all? We grow up seeing clean diagrams of the solar system, the sun at the center, planets orbiting in neat circles, a clearly defined outer edge. But space doesn't work like a textbook diagram. There is no fence in orbit, no warning signal, no cosmic sign that says you are now exiting the solar system. And that creates a deeper question. If there is no visible boundary, where does it actually end? Because it has to end somewhere, right? We're used to borders. Countries have lines on maps, oceans have shorelines, even Earth's atmosphere has layers that eventually fade into space. But the solar system? It refuses to give us that clarity. And that's unsettling, because when you remove a boundary, you remove certainty. If there's no clear edge, where does home stop? Imagine standing on a beach at night. You can see the shoreline, you know exactly where land ends and the ocean begins. Now imagine thick fog rolling in. The shoreline disappears. You walk forward, step by step, and at some point, without realizing it, you're no longer on solid ground. There was no warning, no sign, just a gradual transition. That's what the outer solar system is like. There is no moment where you cross a line. There is only the slow loss of familiarity. And that makes the universe feel far larger and far less contained than we were ever taught. So tonight, we're traveling outward, layer by layer, past every false boundary humanity once believed in, until gravity itself begins to weaken, until the sun slowly loses control, until we reach the place where the solar system doesn't stop, but dissolves. For most of human history, Saturn was the edge. Beyond it, nothing. Then in 1781, Uranus was discovered. Suddenly, the solar system doubled in size. In 1846, Neptune was found even farther out. Once again, the boundary moved. Every generation believed they had discovered the final planet, and every generation was wrong. Neptune orbits about 30 astronomical units from the Sun. 1 astronomical unit, or AU, is the distance from Earth to the Sun. That's about 93 million miles. So Neptune sits roughly 2.8 billion miles away. That sounds enormous, but space is deceptive. If Earth were just 1 yard from the Sun, Neptune would only be about 30 yards away. That's not the edge. That's barely the front yard. The planets aren't the boundary. They're the bright inner decoration of something far larger and mostly invisible. When Pluto was discovered in 1930, people once again thought we had reached the outermost world. But Pluto isn't alone. Beyond Neptune lies the Kuiper Belt, a vast ring of icy leftovers from the formation of the solar system. Thousands of frozen objects orbit here. Some are hundreds of miles wide. Some rival Pluto in size. Yet, if you were drifting through the Kuiper Belt, it wouldn't look crowded. Objects are separated by millions of miles. You'd see darkness, silence, occasional faint sunlight reflecting off distant ice. And yet, everything here still belongs to the Sun, still gravitationally bound, still orbiting. So this can't be the edge, because the Sun is still in complete control. To find the true boundary, we have to stop looking for objects and start following gravity. The Sun isn't just shining, it's constantly blowing outward. A stream of charged particles called the solar wind races away at over 600,000 miles per hour. Over billions of years, that wind has carved out a massive bubble in interstellar space. This bubble is called the heliosphere. It stretches far beyond Pluto, far beyond the Kuiper Belt. Inside this bubble, the sun dominates. Outside it, the thin gas between stars pushes back. Where those pressures balance, there's a boundary called the heliopolis. In 2012, Voyager 1 crossed it. For the first time in history, a human-made object entered interstellar space. Radiation levels changed, magnetic fields shifted, the environment transformed. Headlines declared, "Voyager has left the solar system." But that wasn't entirely accurate, because the heliosphere is defined by solar wind, not gravity. And gravity extends much farther. Imagine continuing outward. No engines roaring, just drifting. The sun shrinks behind you. It stops looking like the center of a system. It becomes just another star. After 1 light year, you're still inside the sun's gravitational influence. After 2 light years, still inside. Nothing dramatic happens, no wall, no barrier, just increasing isolation. The stars no longer twinkle because there's no atmosphere to distort their light. They shine with sharp, steady intensity. And slowly, a realization settles in. The visible solar system was only the bright core. You're now traveling through its ghostly outer territory. Far beyond the Kuiper Belt lies something we've never directly seen, the Oort Cloud, a spherical shell of icy objects surrounding the sun in every direction. Not a flat disk, a sphere. Scientists estimate it begins around 2,000 AU from the sun. It may extend nearly 100,000 AU outward. To understand that scale, Neptune is 30 AU away. The outer Oort cloud may stretch more than 3,000 times farther. Light from the sun takes 8 minutes to reach Earth. It would take over a year to reach the outer Oort cloud. Out there, the sun would look like a bright star, nothing more. This is the birthplace of long-period comets. Some take millions of years to complete a single orbit, but here, gravity becomes fragile. Passing stars tug gently at these distant objects. The tidal pole of the Milky Way itself stretches and distorts them. The Oort cloud isn't just a structure, it's a gravitational negotiation between the sun and the galaxy. About 70,000 years ago, a small star passed relatively close to our solar system. Astronomers call it Schultz's star. It likely moved through the outer Oort cloud. At the time, early humans were already walking the Earth, and far beyond their sight, another sun brushed against the edge of ours. Nothing exploded, nothing lit up the sky, but in the distant darkness beyond Pluto, countless icy objects may have shifted slightly. Tiny gravitational nudges, small orbital changes, and those changes can take millions of years to unfold. A comet disturbed back then might only now be beginning its long journey toward the inner solar system. The sky we see today may contain consequences of an encounter that happened before recorded history. That's how fragile the outer boundary is. It can be touched, disturbed, reshaped by stars that don't even stay. There's one final way to define the solar system's boundary, using pure gravitational math. Every massive object has something called a heliosphere. This defines the region where its gravity dominates over larger external forces. For the Sun, that region may extend 1 to 2 light years outward, nearly halfway to Alpha Centauri. In that distant region, gravity is delicately balanced between stars. An icy object drifting there doesn't clearly belong to the Sun anymore. It exists in a quiet tug-of-war. One close stellar pass could steal it forever. That may be the closest thing to a true edge, not a line, but a fading zone of influence, where control weakens, where ownership becomes uncertain, where gravity slowly gives way. Now zoom out 10 light years away. You wouldn't see planets. You wouldn't see asteroid belts. You'd see one small star with a faint gravitational sphere extending invisibly around it. And every other star has one too. Hundreds of billions of overlapping gravitational territories drifting through the Milky Way, like bubbles in a vast cosmic ocean. Some overlap, some exchange material, some steal from one another. The galaxy isn't made of isolated systems. It's made of interacting regions of influence, blending together over billions of years. So what lies beyond the solar system? Not a wall, not a sudden emptiness, but interstellar space. Thin hydrogen gas, cosmic radiation, dust drifting between stars, and the growing pull of other suns. The solar system doesn't end like a border. It ends like fog thinning into night. You don't step out of it. You slowly realize you're no longer inside it. Our entire planetary system, every planet, moon, comet, asteroid, and frozen fragment, is just one gravitational bubble drifting through a galaxy of hundreds of billions of stars. And somewhere in the quiet overlap between our sun and another distant star, there may be objects that belong fully to neither, balanced between suns, drifting in shared darkness. That's what lies beyond the edge of the solar system. Not an ending, but a transition. And the deeper you travel into space, the more you understand there was never a clear edge at all.